Hi everyone, I'm going to present our paper gSDF, Geometry-Driven Sign Distance Functions for 3D Hand and Object Reconstruction. Given an RGB image, our task is to reconstruct 3D hand and object meshes. Previous works usually use manual, a parametric mesh model to reconstruct the hand of a limited resolution. To alleviate this issue, recent works, for example grasping fields, use deep SDFs to model hand and objects. However, due to the lack of prior knowledge about hands and objects, SDFs are still hard to produce realistic results. Since SDF is a model-free approach, the neural network has to handle both pose estimation and geometry reconstruction during learning. Our idea is to disentangle these two tasks and use poses to guide SDF learning. Here is an overview of our learning framework. Our model mainly consists of three branches: hand pose predictor, SDF feature encoder, and object pose predictor. We first use the hand pose predictor to localize 3D hand key points and use inverse kinematics to recover hand poses. Similarly, since many objects are symmetrical, we employ the object pose predictor to only estimate the object translation relative to the hand wrist. Finally, we use spatial and temporal transformer to aggregate features from multiple frames and produce refined feature maps. Then, given a 3D query point, we produce hand and object kinematic features according to their poses. Also, we fit these kinematic features with queried local visual features into SDF decoders for shape learning. This page shows the process of producing hand and object kinematic features, which is also called point canonicalization process. Compared with a recent work along SDF, we not only consider the poses of the hand wrist, but also includes the full hand kinematic chains of poses, which incorporate stronger prior knowledge about the hand structure. Also, for the object kinematic features, we additionally use the relative translations between the object center and all hand joints, which produce more rich cues for the object reconstruction. On the right part, we show three candidates for the network architectures. They are single backbone architecture, symmetric backbone architecture, and asymmetrical backbone architectures. We observe that when the object pose predictor and SDF feature encoder share the same backbone, our method achieves the best performance. We validate the effectiveness of our methods on Altman and DexPCB benchmarks. We mainly use chamfer distance and f-score to measure the 3D reconstruction quality. We observe that our methods can outperform previous methods by a significant margin in terms of these metrics. In this page, we show qualitative results of our approach on different datasets. We can see that it can recover 3D hand and object faithfully from monocular images. Our methods can also reconstruct objects with thin structures, for example ball, marks, or scissors, of good quality. Thanks for your attention to our work. We have included our codes and poster in our project page. You could also find more technical and experimental details in our paper.